Next, we'll see. So we'll take a second task, that is to find out the biggest number among given three numbers. So I've given with the three numbers, and out of those three numbers, I need to find out which is the biggest one, which is the largest one. Okay. So I am assuming the numbers which I have, three numbers. I'll say the three numbers as A, B, and C. So these are my three numbers. I don't know what exactly the values of A, B, C. I don't know what are the values of the real values of A, B, C. But I'm assuming that A, B, C are three numbers, whatever the values of A, B, C. Okay. So when we start an algorithm, so the first step is we'll write is start the algorithm, and the last step is stop. And in between this start and stop, so we'll try to write down the what is the input for the task. So what are the calculations or what operations you can perform in the task, and finally I'll give the output to the output of the task. Okay, so these are the three steps. You have to blindly follow those three. Remember, without writing these three steps, no algorithm is complete. You will have some input, you'll do some operations, some processing on your input. So after processing that input, you'll give the output. So those are the three steps we follow. But those three steps may involve number of sub steps. Maybe sometimes input is just one line. Sometimes the processing may be a simple like addition of two numbers, just only A plus B is enough. But in some cases, the step of your processing, so it may increase. So the processing step may involve number of sub steps, like it may include some 10 or 20 or 100 sub steps it may include. But the whole thing I call it as some operations I'll apply on the input data. On the input, I'll apply some processing. Maybe I'll do some arithmetic operations, I'll do some logical operations, some kind of operations I'll apply. So the main task of the programmer is what is the sequence of steps you need to follow. That is what you need to identify first. So in that step, so we'll see. Uh, if we have these three numbers, say A, B, and C. So what is the input for this task? So to complete this task, to perform this task, what input you require? So if I'm asking you to tell me what is the largest number of three numbers, what is the thing you expect from me? So leave the program, leave algorithm, nothing. So I'm just talking in normal. If I'm asking you a question, what is the largest of three numbers? So what is the immediate question you pose on me? First of all, you should know, or I should tell you, what are those three numbers. If I tell those three numbers, after doing something, you will tell me, okay sir, this is the biggest number or this is the largest number. So that is what you are expecting is input for the task. What you're expecting what are the values of those three numbers, what are the real values of ABC. So without telling ABC, you can't tell me which is the largest one, right? So that is what my input is. And after you get the input, so you have to find out what are the possibilities of A to become the biggest, what are the possibilities for B to become the biggest, and what are the possibilities of C to become the biggest. So as a programmer, you have to consider all the possibilities. You can't simply say A biggest or B biggest. You have to consider all the possibilities because you don't know the largest number in A or B or C. So as a programmer, your algorithm or your program, it should be in a generalized way. It should not be specific to if the algorithm is finding out only the largest number lies in A, and if it is not identifying if it is in B or C. No, that is not a good algorithm. That is not a correct algorithm. The correct algorithm or the correct program, it should identify the largest number whether it lies in A or B or C. Okay, so you have to think of all the possibilities. So what is the possibilities here? Out of three numbers, you have to find out the biggest or largest. So the largest number lies in any of these three, A, B, or C. It doesn't lies in some other number. It lies in either A or B or C. So you need to identify what are the possibilities of A to become the largest. And next I'll identify what are the possibilities of B to become the largest and C to become the largest. Okay, see, look at the algorithm now. So the first step is start, and second is the first step after start is I will take the input from the user. I'll get the input from the user. So what input I'm taking here is, so I'll get the values of A, B, and C. So what are the values of A, B, and C? So that is my input. So after input, what I'll do, if I get the values of A, B, C, I will start processing that data. I will start processing the data. Here, the step of processing, it includes three steps. It includes three steps. The previous example we have taken, there is only one step, that is A plus B is enough. That itself, A and B are the data you've taken from the user, or else A and B are the input to your task. You are simply writing A plus B, so only a single step on your data processing. But here, that is a different task. So the number of steps are getting increased. Yes, sometimes it includes 100 steps, sometimes it includes 10 steps. The programs depends on the complexity of the program. So initially we're discussing only very simple programs. So the steps of processing it may be like 10 or 15 steps. That's in the very beginning stage. Okay, here, so what is the processing we are doing here? So first, as a programmer, I will choose. So what is the possibility for A to become the largest number? What are the possibilities for A to become the largest number? So when I can say that A is the largest number? So if the value of A is greater than B and the value of A is greater than C, then if the value of A is greater than B and the value of A is greater than C, in that case, what I'll say, I can conclude that A is the largest number. I can conclude A is the largest number. So if A value is greater than C, I will display a statement saying that A is the largest number. If A is the largest number, should I compare with B or C? If I found A is the largest number, is there any point of comparison with the remaining two numbers? Whether the largest number lies in the B or C? No. No need to compare. So what I can do, I'll display that A is the largest number and I will write a statement here. Go to step number 6, because if the output is displayed like A is the largest number, so there is no point of comparing with comparison for B or C to become the largest. if A is the largest. If any of these two conditions, that means A greater than B or A greater than C, if any of these condition fails, if both the condition satisfies, then only I can display that A is the biggest number or largest number. If any of these two conditions fails, I will not display that statement. In that case, what I'll do, I'll go to the step number 4, and here I'm verifying. Else, if the value of B is greater than A and the value of B is greater than C. If not A, I am comparing for the possibility of B to become the largest. What is the possibility for B to become the largest? So now I am verifying if B greater than A and B greater than C. If B greater than A and B greater than C. If these two conditions satisfies, then I'll say display B is the largest number. B is the largest number. If it is displaying that B is the largest number, now what I can do? Here also I can write this statement. Go to step number 6. Go to step number 6. Because if B becomes the largest, no point of verifying for C. So when it comes to step number 4, when the step number 3 fails. So when the step number 3 fails, it indicates A is not the largest. Now the largest number becomes either in B or C. So next, I'm in the step number 4, I'm verifying the possibilities for B to become the largest. So in the step number 3, I ruled out A. In step number 4, I ruled out B. And step number 5. So go to step number 5, and simply because A and B are already ruled out, now I am left over with only C. So now I'll simply go there and I'll display C is the largest number. C is the largest number. So immediately after that, step 5, it will only go to step number 6 only. So stop. So this is the way how we think logically to identify the largest of the three numbers. Yes, you can write down an algorithm for finding the largest of 4 numbers, or you can write an algorithm for finding the smallest of 3 numbers. Yes. So got this algorithm? Hello? So you understood this or not?
Yes, understood.
Yes, sir, we understood everything. Thank you.
Single.
Is it audible to everyone properly?
Yes, sir.
Yes, sir.
Yes, yes. So this is an algorithm for finding the largest of 3 numbers. Okay. So next, moving on to one more example for discussion. So here I am trying to find out the given number is an even number or odd number. I am given with one number and I am trying to find out whether that number is an even number or odd number. Okay, so how can you say that number is even or odd? Any number. How can you decide that number is an even number or odd number?
A number which is divided by uh, 2. I think it's
2.
or 2, 4, 6. Right?
Yes. So simple mathematical kind of operation. So if you divide that number with a 2, and it will give you some reminder. So with that reminder, you can say the answer, whether it is an even number or odd number. Right. So see, so what is the input for your task now? What is the input for the task? So I'm asking you, is 5 even number or odd number? So what is the input for this task? I should give you a number. It may be 5 or it may be 16 or it may be 15. So whatever is the number, I should give one number. If the user is given with one number, then you can say that number is an even or odd. Someone please mute your mic. Thank you. So if I was given with a number, on that number I'll apply some operations, and with the results of that operations I will say that number is an even number or odd number. Okay, see, that number is the input for my task. So without that number I can't do any operation, any processing here. Yes or no? Until and unless I was given that number, I can't do any operation. So that is the input for the task. So first look here, I'll say start, the first step defaultly start, and this is my input part. This is my input part. So what is my input? To read a number from the user, to read a number, get a value from the user, get a number from the user, get a value, any statement of, I already told you, simple English, as simple as possible. So you read a number from the user, so that is the input, and with that number you start applying the operation. Let us assume I have taken one number from the user and I don't know what is that number, the value in that. I'm assuming that number as X. I'm assuming that number as X. So X is having some value, some number. I'm assuming that number as X. Now what I'm doing is, this is the input. So next I'll start applying the operations. I'll try to divide this number X with 2. I'll try to divide this number X with 2. And when I divide the number X with 2 with any number, you do division operation, you'll get the reminder. So what are the possibilities of reminder when you divide any number with 2? If you divide with n, the possibilities of the reminders are 0 to n minus 1. If you divide any number with n, the possible reminders are 0 to n minus 1. If you divide with 2, the possible reminders are 0 to 2 minus 1, which is 1. That means you'll get the reminders either with 0 or 1. Here, in the case of programming, when we talk about a division or something, so we don't discuss generally in the decimal point. That is, you can say, when I divide with 5, it divides with 2.5 times and the remainder is 0. Not that case. I'll try to divide only with the exact division. I'll not keep any decimals in the decimals and keeping zeros in the coefficient. So that part is not included in the programming. That is a normal mathematical division. But see, when I say excuse me, when I say division of 5 with 2, so 2 divides with 5 with 2 times, the 4 and you'll get the reminder as 1. So not keeping a decimal point 0 here, so that is not the case. Okay, we'll not discuss about that. This is purely in the programming. So the division operation, it happens like this. So you'll have, in some cases you'll have that real the decimal part, and that we'll discuss that later. As of now, it is only up to this point. So when I divide any number x with 2, the possible reminders are 0 and 1. So with the values of these reminders, I can decide this x is an even or odd. This x is even or odd. So now I'll consider 0. See, I am writing if the reminder value is 0, then I'll print the number is even number. If the reminder value is 0, then I'll print the number is even number. What if the reminder is not equal to 0? That means if it is 1, I'll say it as else. So else means the reminder is not 0. The other case. So the other case is when the reminder is equal to 1. Then I'll print the number is an odd number. If reminder is 0, I'll print the number is even number. Otherwise, I'll print the number is odd number. What is that otherwise? When the reminder is not 0 or when the reminder is 1. You can say anything. And finally, stop the process. So understood this?
Yes, sir.
Yes, sir.
Thank you.
Yes, sir.
So now we'll come across with a flow chart. So flow chart is also one process of representing the step-by-step process. Step-by-step process, which that is an algorithm also. But here, the step-by-step process is represented visually. Like we'll use some specific symbols are used for representing this step-by-step procedure. Some symbols, instead of writing an English sentence or something, so we'll try to represent that step with some symbol. So a flowchart is a visual representation of the sequence of steps. So those visual representation using some symbols, and in that symbols also we'll write a statement. But simply by looking at that symbol itself, you can identify, okay, the purpose of this step is to get the input, or to display the output, or to perform some operation. So you can identify it easily, even without reading. If you read the text inside that symbol, then you can identify what is the actual step that is happening there. So some fixed symbols will use. If the program is taking some input, so I'll use a symbol. If the program is giving some output to the user, I'll use a symbol. If I'm applying some division operation, some addition operation, I'll use a symbol, some specific symbol. So by looking at that symbol, I can say, okay, this is an input, this is output, this is the mathematical operation. But if I read the text inside that symbol, I can identify, okay, it is a plus b, or is it x plus y, or it is x divided by y. I can identify that. Okay, a flowchart is a visual representation of your step-by-step procedure. Visual representation of the sequence of steps and decisions need to perform a process. So a sequence of steps and the decision. So all the things are included in one process, and that will represent with the visual representation. So each step in the sequence is noted with a diagram shape. That is what I told, a symbol. Some diagram, some symbols or some diagrammatic shapes are used in representing these flowcharts. So I'll give you the list of those symbols or shapes we use in the representation. So these are the symbols we generally use. So first symbol is, it is a rectangle. A rectangle. A rectangle symbol, it is used for representing the process. Any operation you say arithmetic operations, you say some logical operations. So any process that will be represented with the help of this symbol rectangle. The symbol rectangle. Okay, you say previously we discussed some algorithm, so you may come across, yeah, I have written a plus b. That is an operation. I am comparing the values of a with b and a with c. That comparison is one kind of operation. In the previous example, I have written to find out the remainder, I'm dividing x with 2. That is one operation. After getting the remainder, I am comparing the value of the remainder with 0 and 1. That is one operation. So you can do all, you can consider all these things as operations. You can consider all these things as operations. So when we have these operations, we'll use this rectangle symbol for representing those operations. Okay, we can use this rectangle symbol. Indicates any type of internal operation inside the processor or memory. Any kind of internal operation. And next one is, this is a parallelogram. A parallelogram. So parallelogram is used for representing input or output operation. If the algorithm or the flow chart, you want to represent any input or output operation, that can be represented with the parallelogram. So definitely every flowchart will have a parallelogram in the beginning and the ending, because every program will have an input and output definitely. So you'll have a parallelogram for representing input or output operation. Used for any input output operation indicates that the computer is to obtain data or output results. If the program is taking input, I'll use parallelogram. If the program is giving output, I'll use parallelogram. Okay. And next is a rhombus symbol. A rhombus. So what is the purpose of this rhombus symbol is to make any decisions in the program. To make any decision. We'll come across with some decision making statements. Yes, already in the previous algorithms, we come across with some decisions. Look at the first example of first algorithm. In the first algorithm, the values of A and B are given. Simply I'm adding the values. If A and B values are 2 and 5, I'll add 2 plus 5. If they are 5 and 6, I'll add 5 plus 6. Okay. Whereas in the second and third algorithms, the value that I am telling or the output I am giving, it is dependent on the comparisons that I am making in that algorithm. When I'll say A is the largest, if A is greater than B and A is greater than C, with that comparison, I'm making a decision to tell that A is the largest number. Or take the simple the third algorithm. If the remainder is equal to 0, I'll make a decision there to give the output as, okay, the given number is even number. If the remainder is not 0, I will make a different decision there. So that means the output I am giving, it depends on the decision I'll make. I have to, decisions is simply nothing but a kind of comparison. You'll make some comparison. With that comparison, with the result of the comparison, you can say, you can make a decision. So this decision making statement, so it gives a result as 0 or 1, true or false, yes or no. So I'll write like this. Decision making statement. If the remainder is equal to 0. When you are comparing the value of remainder with 0, what are the possible answers you will get? Maybe the remainder is equal to 0, or it may not be equal to 0. Yes, if the remainder is equal to 0, I'll say it as true. If the remainder is not equal to 0, the statement is false. So for any decision making statement you write, you will get the possible answers as true or false. You'll get the possible answers as true or false, or you can say yes or no. If the remainder equal to 0, yes. If the remainder is not equal to 0, you can say no. Okay, so the decision making statements, so we'll write them like this, either true or false or yes or no kind of results you'll get. So based on the result of that, you will make a decision. Okay, to display that number is even, or to display that number is odd. So on what basis you are saying them as even or odd? On the basis of this reminder. So always when you write a decision making statement, you will have two possibilities from that decision making statement. The possibilities are two, which are true or false, which may be yes or no. So these are the possibilities you will get. Okay, so this is about decision making statement. So we'll look at this and very clear when we come across with one example. Okay, and next one is the connector. So the purpose of this connector is when there is a possibilities of the lines getting intersected. That means you are writing a flowchart algorithm like this. You have a processing statement here, and you have a decision making statement here. And from this processing, from this decision making statement, you have something, a line getting overlapping. So when the lines are getting overlapped here, so we'll not write like this. We'll not write an overlapping lines like this in the algorithm. So in that case, what we'll do is we'll write this connector symbol. Or Connectors are also used in the situations like when the algorithm is sorry when the flowchart is not getting fixed in one particular page, when you are drawing in a notebook or in a paper, if it is not confined to one page, so at the end of the page I'll write this connector symbol, and I'll place some constant here, say it as alpha, some constant, any constant you can write. You can place alpha, you can place dollar symbol, you can place at the rate symbol, any special character you can place. And the continuation, if I am drawing in the second page, so there I will start with the same symbol. Let us say this is page number 1 and this is page number 2, and in the second page I will start with this the same symbol I have to use here, so that indicates that it is a continuation of the page. Okay, in very rare cases we'll use this connector symbols. And this is rectangle. This is a predefined process, so we'll discuss this not now. We'll discuss about this symbol later. And one more symbol we have here is a terminal, so which indicates the starting and ending of the program. The starting and ending of the program is represented with this. This is a round edged rectangle, or you can also use a symbol oval. You can use a symbol oval, or you can use a round edged rectangle, not a normal rectangle. A round edged rectangle can be used for representing start and end of the process. You can use anything. And these are the arrows. Arrows. We will call them as a flow lines. The flow lines, the name itself is the flow chart. It represents the flow of your step by step. So what is that flow? After this step, the flow is in this direction. I'll write an input or output input a statement here. I'm sorry. And after this input, I'll make a decision making statement. For a decision making statement, the flow may be in two directions, maybe in this direction or maybe in this direction, based on the true or false, or maybe on the based on yes or no. So we'll write this arrow symbols to connect the all the remaining symbols. Arrows are used to connect the symbols, and it also shows the direction of in which direction the data or the process is getting flow. So by looking at this, you can identify, okay, after this, it is second statement, the flow is in this way. The flow is in this way. The flow is based on this true, it is in this way. Based on false, this is in this way. Okay, so based on that flow, you can identify. So that is why the name is flow chart.
Sir, sir, can you repeat from predefined process?
What?
Sir, can you repeat from predefined process?
Predefined process, I have not discussed about predefined process. Will discuss it later.
Okay, sir.
That is when you can understand as of now that symbol. So will not that is used in very rare cases actually. When we use the functions or when we use subroutines, then we'll use that. But as of now, you don't know that, so I can't explain all that stuff now.
Okay, sir. Can you explain about connector?
Yes, connector. So connectors, they are just when you are writing an when a flow chart. So say you are drawing a flow chart on a piece of paper, and the whole flow chart of that task, it is not getting fixed in one page. You are writing or you are drawing the flow chart in multiple pages. So that case, what I'll do is at the end of this page, I'll use this connector symbol. That is just a small circle. And inside this connector symbol, I'll use any symbol here. I'll say I'm using a dollar. The same symbol has to be used in the page where you are continuing this flowchart. Suppose if I start drawing the remaining part in the second page, here the first symbol I need to use is this connector with the same symbol. And then here I can continue with the remaining symbols or shapes. Whatever I want, I can do. So this is what a connector is.
Okay, sir. Thank you.
So we'll look at one example for flowchart. So this is a flowchart for addition of two integers. Flowchart for addition of two integers. So we already discussed the algorithm. So what is algorithm? So first is start, and then I'll get the value for those two numbers, adding those two numbers, so storing the result into the some other variable, and display the value, and finally end up the process. So the same algorithm, you can open that algorithm, you can check. Maybe the wordings may change here, but the ultimate task is same. The steps in the algorithm I'm representing with these shapes. The first step here is start. So start can be represented with oval or a round edged rectangle. You can use any of these two symbols for representing the start and stop of the process. Starting and ending of the process. And next, I am taking input for two values. So what numbers I need to add? I am adding input which is number one. I am taking it as number one comma number two, or you can say a comma b. You can say x comma y. Any two names you take. I am taking it as a number one and number two. Now adding those two numbers and placing that into a variable called sum. You can say c is equal to a plus b. You can say c is equal to number one comma number two, number one plus number two. Sum is equal to number one comma number two. So anything you can write. So this step is processing. You are performing addition operation. So that is one, processing. Number one plus number two, and you are storing the result. So any process statement can be represented with a rectangle. And next, you need to display the value of that sum. So that sum can be displayed with the help of this parallelogram, because it is an output statement. Output statement can be displayed using a symbol parallelogram. And finally, end the process. So got it? So look at one more example. So this is a flowchart for finding the given number is even number or odd number. See, a rounded a oval shape for representing the start symbol. So you need to input, you need to read a number. So input a number. So that number can be represented with a parallelogram. And once you have taken that number, you have to calculate the remainder. And after getting the remainder, so now you are comparing the value of that remainder with 0. So here you can see that symbol, like a percentage symbol is there. In programming, that percentile symbol, we call it as a modulo. So as of now, you just remember that percentage symbol, it will give me the remainder. Okay, I'm comparing that remainder value with 0. When you are comparing, if it is yes, the flow will go in this direction and it displays that number is even number. It displays that number is even number. And after displaying that number is even number, I'll go here and I'll say stop. When this is not equal to 0, that means when the remainder is equal to 0 is false. That means when it is no, in that case, the flow will go in this direction. If it is yes, it will go in the left side direction. If it is no, it goes in the right side direction. The flow is different based on the value of the remainder I get. The value of the remainder is 0, I'll go in the direction which I have represented with that pink color line. If the statement I have written there is false, that is no, that goes in this direction which I am writing it in green colored line. So in that case, I'll display it as odd number, and after displaying that as odd number, I'll go here and I'll say stop. So whether I display it as even number or whether I display it as an odd number, at the end I have to stop the process. You can write it as a start, stop. You can write it as a start, end, anything. Okay, but at the end you have to stop the process. That means whatever you display, whatever operations you do, but finally you have to reach to end of the task. That is what the finiteness of the algorithm. Got it? So with this, I'll stop for today's session. So if you have any doubts, you can just ask me.
No, sir. It's fine for us. Thank you.
Thank you, sir.